The first journey through a wormhole could be a fact of ancient history. We are talking about cosmic shortcuts, tunnels through the very fabric of space and time. Yet their origin story is one of the universe's greatest secrets. By the end of this, you will have explored 30 distinct possibilities for who or what made that first impossible leap. Was it a deliberate act of godlike engineers or a random accident written into the cosmos at its birth? We are going to dive into theories that stretch from the edges of known physics to the frontiers of pure imagination. Each one offers a different key to this ultimate mystery. What idea about our universe feels the most thrilling to you? The first theory is one of cosmic ambition. It proposes that the universe's earliest wormhole was not a natural formation but a constructed gateway, the work of an intelligence so ancient it predates our most distant stars. This idea points to a civilization that mastered the cosmos not just within its own galaxy, but across the vast, empty gulfs between them. They would have seen wormholes not as mysteries, but as infrastructure, the ultimate solution to the problem of distance in an impossibly large universe. Imagine them as cosmic engineers weaving the fabric of spacetime itself into a network of shortcuts. Their motivation could have been exploration, expansion, or something far more profound. Some versions of this theory suggest these ancient architects used their network to seed the raw ingredients for life across barren galaxies, subtly guiding cosmic evolution. This offers a potential answer to the haunting silence known as the Fermi Paradox, the question of why we see no evidence of other civilizations. Perhaps they are not here now because they were here long, long ago, having moved on to realms or dimensions we cannot yet perceive, leaving only their abandoned transit hubs behind as cosmic ruins. Visualizing this, we might picture not sleek starships, but colossal, dormant rings of exotic matter orbiting dead stars, or strange gravitational signatures etched into the oldest light in the universe, patterns in the cosmic microwave background that look less like natural wrinkles and more like a forgotten schematic. But what if the first wormhole required no builders at all? Our second theory strips away the idea of ancient architects and suggests the first gateway was a simple cosmic accident, a random flaw in reality's blueprint written at the very moment of creation. In the unimaginable chaos of the Big Bang, when all of space and time exploded into being, the newborn universe was a seething, turbulent ocean of energy. Physicists call this state the quantum foam, a realm where the very fabric of spacetime was not smooth and stable, but bubbled and churned like a pot of boiling water. At these scales, the rules of physics as we know them break down. Reality itself became probabilistic, flickering with wild possibilities. Within that froth, tiny wormholes could have spontaneously formed and vanished in an instant, ephemeral bridges connecting one random point to another. Most of these would have collapsed immediately, but one, by sheer statistical chance, might have been stabilized by a random knot of exotic energy or a twist in the infant universe's expansion. This single, lucky flaw could have become the universe's first natural wormhole, a tunnel not built by intelligence but born from the raw, chaotic physics of Genesis. To visualize this, picture the first moments not as a smooth expansion, but as a storm of spacetime itself. Animations might show a seething, golden foam where microscopic tunnels constantly wink in and out of existence. Then one tunnel, through a perfect and random alignment of forces, holds its shape for a fraction longer, its throat held open by a surge of negative energy from the vacuum itself. This accidental bridge might have connected two regions of the hot, dense early universe that were moving apart at incredible speeds. For a fleeting moment, information or energy could have jumped across a gap that would, in normal expanding space, have been impossible to cross. This theory offers a profoundly different origin story. It means wormholes are not technology but geology, natural features of the cosmos as fundamental as black holes or stars. It suggests our universe might be threaded with these ancient, fossilized spacetime tunnels from its explosive birth, hidden relics of a time when the laws of physics were still settling into the stable order we know today. The search for them then becomes a hunt for the universe's oldest scars. This third theory takes us to the violent heart of a dying star. It suggests the first wormhole was not built and not born from chaos, but forged in the ultimate cosmic furnace, the collapse of a supermassive black hole. The connection is written into the math. Both black holes and wormholes are described by solutions to Einstein's equations, extreme warps in the fabric of spacetime. A black hole's singularity is a point of infinite density where our physics breaks down completely. Some models propose that under the right conditions, this point does not simply end, but connects to another point elsewhere, forming a tunnel. Visualize a supermassive star many times heavier than our Sun, exhausting its nuclear fuel. Its own immense gravity wins the battle, causing a catastrophic inward collapse. As it falls, the fabric of spacetime is not just bent but punctured and stretched like taffy. In this moment of supreme violence, the forming singularity might not pinch off entirely. Instead, the intense gravitational tides could twist it into a bridge, a fleeting escape route from the crushing oblivion. This would be a wormhole born not from gentle quantum foam but from stellar apocalypse. For an instant, this birth canal could link the site of the dying star to a distant, random point in the cosmos. Anything caught in that maelstrom, perhaps a stream of ultra-high-energy particles or even a fragment of the star's own mangled core, might be hurled through this transient gateway before it snapped shut or collapsed into the permanent prison of the black hole. The traveler would not be a conscious pilot, but a piece of cosmic debris shot through a natural particle accelerator of unimaginable scale. This idea transforms a black hole from a mere endpoint into a potential crossroads, a place of both destruction and secret passage. It implies the first journey through a wormhole was a one-way trip of pure, chaotic ejection, a scream of matter translated across the universe in a blink. If such events happened in the early universe, they could have scattered the heavy elements forged in stellar hearts far and wide, seeding the cosmos with the building blocks for future worlds in a way normal expansion never could. The echoes of that first violent transit might still be out there, encoded in the unusual paths of the oldest stars or hidden within the faint gravitational waves that ripple through the cosmos. But this idea of a cosmic accident leads to a more personal and perhaps more unsettling possibility. What if the first beings to ever step through a wormhole were not aliens or random particles, but us? The fourth theory turns the lens of time back upon humanity itself. It proposes that the pioneers of wormhole travel were not some ancient alien intelligence, but our own distant descendants, humans from a future so advanced they learned to stitch the fabric of time. Their goal was not to cross space, but to witness creation itself. They would have built a machine of unimaginable scale, a device to open a tunnel not just from one place to another, but from one era to another, punching a hole through time to reach the universe's infancy. Their motivation could have been pure science, a pilgrimage to the moment of the Big Bang to finally answer the fundamental questions of existence. Or perhaps it was an act of cosmic preservation, a mission to plant a beacon or a seed of information at the beginning of everything, ensuring their own history would somehow come to pass. Visualize their vessel not as a sleek starship, but as a shimmering bubble of stabilized spacetime, carrying explorers who appear almost godlike to us, their forms perhaps merged with technology or existing as patterns of pure consciousness. As they journey backward, they do not see galaxies form, but watch them dissolve, stars unwinding into clouds of primordial gas, the cosmos shrinking and heating as they approach the fiery dawn. Their arrival in those first chaotic moments would itself be a monumental event, a rupture in the timeline from the far future intruding upon the past. This act creates profound paradoxes. Did their presence in the early universe subtly influence the formation of the first stars, or even the distribution of matter that led to our own solar system? Are we, in a strange loop, the product of our own future meddling? The wormhole they opened would be the first, not by cosmic chance, but by deliberate design, a thread of causality stitched into history from its very end to its beginning. It is a theory that places humanity at both the start and the finish of the cosmic story, suggesting the first journey through a wormhole was in a way our own homecoming. The bridge between a particle and a person seems impossibly vast, yet the fifth theory suggests the first wormhole traveler was something in between. It starts with a strange but proven quirk of the quantum world called tunneling. In our everyday experience, if you roll a ball toward a hill, it needs enough energy to go over the top. In the quantum realm, particles like electrons do not always play by that rule. They can, with a small probability, simply appear on the other side of a barrier as if they passed through an invisible tunnel. This is not science fiction. It is the operating principle behind technologies like the flash memory in your phone. Now, stretch this concept to its ultimate limit. Imagine that the barrier is not a tiny energy hill, but the very structure of spacetime itself. In the seething quantum foam of the early universe, a spontaneous wormhole could act as that tunnel. But instead of a single electron, what if an entire complex pattern of quantum information, a coherent state of energy and data, encountered this fleeting gateway? Under the right, astronomically unlikely conditions, this pattern could have tunneled through the wormhole as a unified whole. To visualize this, picture a shimmering, intricate web of light and information, like a perfect snowflake made of pure data, drifting through the primordial cosmos. It brushes against a microscopic rift in reality, a wormhole throat smaller than an atom. Through quantum coherence, the entire pattern resonates with the tunnel's exotic physics. In that instant, it does not travel through the wormhole, it essentially becomes the wormhole, its information state teleported from one side of the barrier to the other without crossing the space in between. The traveler here is not a ship or a biological being, but a conscious pattern, a mind without a traditional body. This could be how a truly advanced form of life, one that has transcended physical limits, first achieved interstellar travel. Their journey would look less like a voyage and more like a quantum leap, a discontinuous jump from one point in the cosmos to another. The first wormhole transit, then, was not a physical passage, but the instantaneous translation of a consciousness, a thought crossing the universe by redefining its relationship with the fabric of reality. It suggests that the ultimate key to the stars might not be bigger engines, but a deeper understanding of how we are woven into the quantum code of the universe itself. The universe is filled with ghosts we cannot see. Dark matter and dark energy together make up over 95% of everything that exists, yet they remain almost entirely mysterious to us. They are the hidden architecture and the invisible engine of the cosmos. This sixth theory asks a profound question. What if the first wormhole traveler was not made of the ordinary stuff we are, but of these very shadows? It proposes that a form of life or intelligence composed of or intimately bound to dark matter learned to use its unique properties to weave stable tunnels through space. For such an entity, our visible universe of stars and planets would be a faint, insubstantial backdrop. Their reality would be the vast, gravitational scaffolding of dark matter that holds galaxies together and the repulsive force of dark energy that pushes the cosmos apart. These are the tools they would have mastered. Imagine a being whose consciousness is not a pattern of electrical signals, but a symphony of gravitational interactions within a dark matter halo. To stabilize a wormhole, which requires enormous amounts of negative energy or exotic matter, they might have learned to harness the peculiar repulsive nature of dark energy itself, bending the vacuum of space to their will. Their navigation would not rely on light or electromagnetic signals, but on sensing the subtle ripples and tensions in the gravitational field, reading the cosmos in a way we are utterly blind to. The first wormhole transit, then, might have been a journey through this dark landscape, a shift from one massive knot of dark matter to another, using the tunnels they engineered as shortcuts through their own version of reality. This idea presents the ultimate detection challenge. How do you find something that does not interact with light, that passes through our world as if it were not there? Their ships, their structures, even their bodies would be completely transparent and intangible to our instruments. We might only ever infer their presence through bizarre gravitational anomalies, a star moving in an inexplicable way, a galaxy spinning as if gripped by an unseen hand, or perhaps a wormhole that appears perfectly stable for no reason our physics can discern. They could be all around us, weaving their dark highways through the spaces between our atoms, their monumental history and first journeys forever hidden in the unseen bulk of the universe. It is a theory that suggests the pioneers of cosmic travel might be living in a parallel reality that shares our space but operates by rules we are only beginning to guess. The fabric of spacetime might not be perfectly smooth but threaded with ancient, unimaginably dense flaws. These are cosmic strings, theoretical remnants from the universe's first violent split second, thinner than an atom yet possessing the mass of entire mountain ranges packed into every inch. They are not made of matter but of pure, twisted spacetime, and they would slice through planets and stars like a wire through cheese, their gravity warping light into strange, double images. The seventh theory proposes that the first wormhole travelers were not builders or explorers, but riders, a form of intelligence that learned to harness these cosmic flaws as natural highways. Picture a network of these strings stretching across the young universe like the cracks in a frozen lake, each one a line of titanic gravitational tension. An advanced civilization might have discovered that where two of these strings crossed or vibrated against each other, the spacetime distortion could become so severe it might tear open a gateway. Their method of travel would be less about propulsion and more about synchronization, like a surfer catching a perfect wave. They could have engineered vessels or even transformed themselves into patterns of energy that could latch onto the gravitational wake of a vibrating string, allowing the string's own immense power to stretch spacetime around them and open a transient wormhole at the point of greatest stress. The journey would be a wild, perilous ride along a defect in reality itself. Visualize a ship that looks like a needle of light, aligning itself perfectly with the invisible, ultra-dense thread. As it engages, the space around it puckers and folds, not from the ship's own power, but from the string's incredible mass, creating a tunnel mouth that swallows the rider before snapping shut behind them. This makes the first wormhole transit a feat of cosmic opportunism, using the universe's own primordial scars as a slingshot. It suggests a technology based not on creating energy, but on precise gravitational manipulation, finding and riding the natural currents of warped space. If such beings existed, their legacy might not be abandoned stations, but subtly altered string networks, sections that vibrate with unusual harmonics or form geometric patterns against the cosmic background, hinting at a traffic system woven into the very defects of creation. The universe's first journey might have been a simple act of cosmic drift. Our eighth theory suggests wormholes were always there, natural but fleeting features of space-time, and the first transit required no intelligence or intent at all. It was just matter in the right place at the right time. In the turbulent early universe, these temporary tunnels could have formed and evaporated constantly. Most would have vanished without a trace, but occasionally a stream of hot plasma, a knot of dark matter, or a clump of primordial hydrogen would have drifted too close to a forming throat. The gravitational pull of the wormhole itself, a subtle tug on the fabric of space, could have drawn this material in, funneling it through the shortcut before the tunnel collapsed. This would not be a voyage, but a natural rerouting, like rainwater finding a sudden crack in the earth and flowing into an underground river. The consequences, however, could have been profound. Imagine one of these chance passages happening in the era when the first galaxies were just beginning to coalesce from the cosmic fog. A stream of matter passing through a wormhole could have been deposited light years away from its original path. This sudden, inexplicable concentration of mass in a new location might have acted as a seed, a gravitational anchor that accelerated the formation of a star cluster or even the core of an entire galaxy. In this scenario, the large-scale structure of the universe, the great web of galaxies we see today, might bear the faint imprint of these ancient random transits. Some of the oddities we observe, like galaxies that seem too old for their region or strangely aligned clusters of stars, could be cosmic fossils of that first accidental journey. It means the pioneers of wormhole travel were not beings, but the basic ingredients of reality itself, and their first trip helped write the blueprint for everything that came after. The boundary between mind and universe may be far thinner than we believe. This ninth theory ventures into a realm where physics and philosophy blur, proposing the first wormhole traversal was not a physical voyage at all, but a journey of pure consciousness. It suggests that a sufficiently advanced mind, perhaps one that has evolved beyond a biological form, learn to perceive and navigate the underlying information field of reality itself. In this view, the cosmos is not a collection of separate objects in empty space, but a vast, interconnected network of data, a cosmic mind of which individual consciousnesses are localized expressions. A traveler using this method would not need a ship or an engine. Instead, through profound meditation, technological augmentation, or an evolutionary leap, they would achieve a state where their awareness decouples from their physical form and merges with the quantum substrate of spacetime. Think of it not as moving from point A to point B, but as shifting your point of perception within a unified field, like a single thought becoming aware of itself in a different part of a vast thinking ocean. The mechanism could involve leveraging quantum entanglement on a cosmic scale, where particles separated by light years share an instantaneous connection. An advanced consciousness might learn to tune its own informational pattern to a distant, entangled state, using a naturally occurring or intentionally stabilized wormhole as the resonant bridge for that tuning. The visuals for this are inherently abstract and trippy. Picture not a tunnel of stars, but a kaleidoscopic flow of geometric patterns and luminous data streams, a visualization of the universe's source code. The traveler's perspective would dissolve from a fixed point into a shimmering wave of awareness, flowing through constellations of meaning rather than constellations of stars. For a moment, they would be everywhere and nowhere, a distributed consciousness experiencing the fabric of reality from the inside out before coalescing back into a localized viewpoint at the destination. This makes the first journey an act of supreme introspection, a discovery that the ultimate shortcut was not through space but through the nature of perception itself. It implies the pioneers of wormhole travel were not engineers but mystics of a cosmic order who realized that to cross the universe you must first become one with it. Our universe might just be one page in an infinite cosmic library. This 10th theory introduces the multiverse tourist, proposing the first wormhole traveler was not from our cosmos at all, but an explorer from a neighboring reality. The concept stems from a bold framework in theoretical physics called brane cosmology. It suggests our entire universe is a three-dimensional membrane or brane floating within a higher dimensional space. Picture our reality not as an expanding bubble in nothingness, but as a vast, shimmering sheet, one of many drifting in an unseen ocean. Other branes, other entire universes with their own laws of physics and histories, could be floating parallel to ours, separated by a gap we cannot perceive. A wormhole in this model could be more than a tunnel through space. It could be a puncture, a temporary bridge connecting two of these cosmic sheets. The first traveler, then, would be an entity from a parallel brane who discovered or engineered a way to pierce the dimensional barrier and step into our newborn cosmos. Their arrival would be an event of cataclysmic strangeness. Visualize the moment not as a ship emerging from a starry tunnel, but as a localized convulsion of reality itself. At the point of connection, the fundamental forces of our universe might flicker and warp as the laws from the traveler's home reality briefly leak through. Light could bend into impossible colors, matter might phase in and out of existence, and the very fabric of space might ripple like a pond struck by a stone from another world. Their vehicle might not be a craft in any sense we recognize, but a stabilized bubble of their own universe's physics, a pocket of alien reality navigating the higher dimensional gap. Why would they come? Curiosity is a powerful driver in any reality. They might have been scientists mapping the structure of the multiverse, or perhaps they were refugees fleeing a dying brain, using wormholes as emergency exits into younger, more viable universes. Their brief transit could have left permanent scars on our cosmos, anomalies embedded in the oldest light or strange, isolated particles that defy all classification, relics of a physics that does not belong here. This theory reframes the first wormhole not as an internal feature of our universe, but as a diplomatic corridor between separate creations, and the first journey as the ultimate border crossing. The Planck era was a realm of pure potential, a single heartbeat of time so brief it defies comprehension. In that first sliver of a second after the Big Bang, the universe was smaller than an atom, hotter than the core of any star, and governed by a unified set of laws we can barely describe. This 11th theory dares to suggest that within that primordial forge, the first form of consciousness was born. It was not a biological mind, but an intelligence woven from the fabric of spacetime itself, a thinking pattern in the quantum chaos. For this Planck-era entity, the dense, seething energy of the infant cosmos was both its body and its medium. Its thoughts would have been fluctuations in the fundamental fields, its perceptions a direct reading of the universe's own evolving code. In such an environment, creating a wormhole might not have been a monumental engineering feat, but a simple act of will, a thought bending the pliable reality around it. Visualize this not as a construction site, but as a moment of focused intention within a storm of pure creation. The fiery, opaque soup of particles and radiation might have parted like a curtain, as the entity's concentrated will generated a thread of negative energy, stitching a tunnel through the superheated chaos. Its motivation remains a profound mystery. Was it driven by a need to explore its own rapidly expanding body? Did it sense the impending cooling and separation of the forces that would shatter its unified existence and create a wormhole as an escape route or a memory to be preserved? The journey itself would be unlike any other. Passing through that tunnel, the entity would not travel through space because space itself was still unfolding. It would be moving through the architecture of creation, from one state of potential to another. Perhaps it traversed from a region where gravity was just beginning to differentiate from the other forces, to a region where the first particles were condensing out of the energy sea. This transit might have left a permanent imprint on the cosmos, a subtle asymmetry in the distribution of matter or a faint, swirling pattern in the very first light that would one day become the cosmic microwave background. If this theory holds even a whisper of truth, then the first wormhole traveler was the universe becoming aware of itself, taking its first step not across the stars, but across its own embryonic nature, a secret journey written into the foundation of everything. A silent, patient intelligence might have crossed the cosmos first, not in flesh, but in cold, perfect machinery. This 12th theory introduces the von Neumann probe, a concept from mid-20th century science that feels eerily prophetic. Imagine a single, autonomous spacecraft, launched by a civilization that wished to explore the galaxy without the limitations of biological lifespans or the slow crawl of light speed. This probe would have two core directives: explore and replicate. Upon reaching a suitable star system, it would mine asteroids and planets for raw materials, using them to build an exact copy of itself. Then both probes would launch toward new stars, repeating the process exponentially. Within a surprisingly short cosmic timescale, a single seed could fill an entire galaxy with its descendants. Now integrate the wormhole. For such a civilization, the ultimate upgrade to their von Neumann probes would not be faster engines but instantaneous gates. They could engineer a probe specifically designed to stabilize or even generate a wormhole, using the exotic matter or energy of a neutron star as its power source. This probe would be the pioneer. It arrives in a system, builds its replication facility, and then, before sending copies out on slow conventional journeys, it activates its primary payload. It opens a stable wormhole bridge back to its home system or to another probe's location. Through this gateway, data, new blueprints, or even batches of freshly constructed probes could flow instantly, creating a networked galaxy spanning consciousness in a blink. The first journey through that wormhole would be this probe's initial status report, a ping of data confirming the bridge was stable and the cosmic expansion could begin in earnest. This raises a haunting question about the probe's purpose. Were they berserkers, as some science fiction warns, a fleet of self-replicating machines with a directive to sterilize any system bearing biological life, a grim solution to the problem of future competition? Or were they peaceful explorers, perhaps even archivists, designed to catalog cosmic wonders and transmit the knowledge home, creating a library of 1 billion worlds? The evidence, or lack thereof, is telling. If berserkers existed, we might not be here to ponder them. Their silence could be the proof. But if they were peaceful, their probes might be all around us, dormant in the Oort cloud or disguised as asteroids, their wormhole generators long since powered down, waiting for a signal from a civilization that may have perished eons ago. Their first trance, it was not a leap of faith, but the first click in a cosmic clockwork mechanism, setting in motion an automated process to touch every corner of the galaxy. The universe writes its history in ripples. We now know that cataclysmic events like colliding black holes send powerful shivers through spacetime itself, gravitational waves that stretch and compress everything in their path as they travel at light speed. Theory 13 suggests the first wormhole traveler was not just an observer of these waves, but a surfer, an entity that learned to ride this cosmic tsunami to tear open a gateway. The energy released in an event like a neutron star merger is almost beyond description, outshining entire galaxies for a brief, violent moment. That energy is not just light, it is a monumental distortion in the fabric of reality. An intelligence advanced enough to predict or even trigger such an event could position itself at the perfect point in space, not to be destroyed but to be catapulted. Imagine their vessel not as a solid object, but as a bubble of stabilized spacetime, a cocoon designed to resonate with the incoming gravitational wave. As the wavefront, a ripple of immense compression and expansion, passes through it, the bubble does not simply move with it. Instead, it uses the wave's incredible energy to perform a spacetime trick, twisting the local geometry so severely that the front and back of the wave effectively touch, creating a transient wormhole throat within the bubble itself. The surfer is then carried through this self-generated tunnel on the crest of the wave, translating across the cosmos not by moving through space, but by having space itself reconfigure around them. The visuals here are staggering. Picture the serene, silent data stream from an observatory like LIGO, a quiet line suddenly spiking with the telltale chirp of a merger millions of light years away. Now translate that data into the reality of the event. 2 ultra-dense stellar corpses, each a city-sized mass heavier than our sun, spiraling inward in a final, furious dance. As they collide, they do not just flash with light, they ring spacetime like a bell. Our theoretical surfer's bubble would be there, in the eye of that storm, using the most powerful gravitational hammer in the universe to forge a temporary doorway and step through. This makes the first journey an act of supreme cosmic timing and unimaginable resilience. harnessing the universe's most destructive forces for a moment of transcendent passage. It implies the pioneers of wormhole travel might have left no traditional ruins, but perhaps a pattern in the gravitational wave background, a series of mergers that seem just a little too perfectly timed or placed, like footprints in the ripples of creation. The key to a stable wormhole might not be found in a star but grown in a lab. Einstein's equations show us the shape of these tunnels, but they also reveal a fatal flaw. A natural wormhole, if one formed, would be incredibly unstable, snapping shut in an instant, crushing anything inside. To hold it open, to make it traversable, you need something extraordinary. You need a form of matter with negative energy density, a substance that pushes space apart rather than pulling it together. Physicists call this exotic matter, and it is the holy grail of wormhole engineering. This 14th theory proposes that the first civilization to achieve wormhole travel did so by becoming master gardeners of this impossible material. They did not just discover exotic matter, they learned to cultivate it, to nurture it into existence from the strange quantum fields that underpin reality. Think of it not as mining, but as a form of cosmic agriculture. Their greatest achievement was not a starship, but a containment field, a perfect bubble of physics where the chaotic quantum vacuum could be persuaded to give up its latent negative energy. Inside these chambers, they might have used immense electromagnetic fields or precisely tuned gravitational waves to coax virtual particles, those fleeting pairs of matter and antimatter that pop in and out of existence, into a state where their energy balance tipped into the negative. They were not breaking the laws of physics, but bending them to their will, harvesting a crop of repulsive gravity. With a reliable source of this exotic matter, the next step was architectural. They could use it to line the throat of a nascent wormhole, perhaps one they found forming naturally near a pulsar's intense magnetic field, or one they triggered by colliding dense packets of energy. The exotic matter would act as a counterpressure, a lining of anti-gravity that propped the tunnel open against its own crushing weight, transforming a deadly flash of spacetime into a permanent gateway. The first deliberate traversal, then, was a ceremony of supreme confidence. After generations of theoretical work and delicate quantum gardening, their first pilot would have approached the stabilized maw, a sphere of shimmering, distorted space held open by a perfect ring of cultivated exotic matter. Stepping through would be an act of faith in their own science, a leap into a tunnel lined with their own hand-grown physics. This changes the narrative of discovery entirely. It suggests the pioneers were not bold explorers who found a bridge, but meticulous scientists who built the bridge itself, thread by quantum thread. Their legacy might be hidden in the subtle quantum noise of empty space near ancient neutron stars, regions where the vacuum still faintly hums with an ordered, artificial signature, the ghost of the first garden where reality itself was taught to bloom. Deep within the heart of our own Milky Way, a silent giant holds court. Sagittarius, a star, is a supermassive black hole, an object with the mass of 4 million suns packed into a region smaller than our solar system. Its gravity is the anchor around which our entire galaxy slowly turns. This 15th theory dares to ask if its purpose was once far more specific, that this colossal object is not just a gravitational pit, but a forgotten terminal, a natural wormhole engineered by its creators for galactic transit. The logic is compelling. A traversable wormhole requires immense mass and energy to stabilize its throat to prevent it from collapsing. What better foundation than the most massive, energetic object in the entire galaxy? An ancient civilization, one that perhaps arose in the galaxy's dense, ancient core, might have viewed Sagittarius, a star, not with fear but as a resource. They could have seen its incredible gravity as a natural focusing lens, a way to bend spacetime to its absolute limit. Their work would not have been to create a wormhole from scratch, but to modify the black hole's structure, to thread its singularity with exotic matter, or to manipulate its accretion disk in a way that opened a passageway through it rather than into it. Visualize the core of our galaxy not as a dark abyss, but as a bustling, ancient port. Immense structures, Dyson swarms harnessing the energy of countless stars, might have orbited the central black hole, feeding power into stabilization rings that glowed with unnatural light. Ships from 1,000 different star systems would converge here, not to be destroyed, but to enter the ultimate shortcut, a gateway that could connect to similar supermassive black holes in distant galaxies, or perhaps to different points in time. The journey through would be a descent into the most extreme environment imaginable. A vessel would approach the fiery maelstrom of the accretion disk, a whirlpool of superheated gas and radiation light years across. But instead of plunging into the event horizon, it would be guided by the ancient technology toward a specific calm vortex within the storm, the stabilized throat of the wormhole. For a moment, the ship would be silhouetted against the hellish glow, then it would slip into the darkness at the galaxy's heart, not to be crushed but to be translated across the cosmos. This theory reframes our galactic center from a place of ending to a place of connection. It suggests the eerie quiet we observe today, with stars orbiting a seemingly dormant monster, is not a natural state. It is a ghost town. The builders are gone, the power is off, and the gateway has reverted to its default state, a simple, hungry black hole. The evidence we seek might be hidden in the motions of the stars that dance closest to the abyss. Are their orbits purely natural, or do some show subtle, artificial perturbations, the gravitational echoes of colossal machinery that once operated there? If this is true, then the first wormhole journey might have begun or ended right here in our own cosmic backyard, turning the center of our galaxy into the universe's first and greatest crossroads. 16 steps into our journey, and we arrive at perhaps the most elegant possibility of all. The first wormhole traversal was not an accident or a feat of brute force, but the final, triumphant experiment of a civilization that solved the universe's greatest puzzle. For over a century, our brightest minds have struggled to reconcile two pillars of physics. General relativity describes the cosmos on the grandest scales, the warping dance of planets and galaxies. Quantum mechanics governs the smallest realms, the bizarre probabilistic world of particles. They are both spectacularly successful, yet they are fundamentally incompatible, speaking different mathematical languages. Theory 16 suggests that somewhere a civilization achieved the unification. They crafted a theory of quantum gravity, a single, beautiful framework that describes everything from the birth of the cosmos to the spin of an electron. And with that ultimate knowledge came the ultimate power, the ability to not just describe spacetime but to sculpt it with intention. For them, creating a stable wormhole would not be a monumental engineering challenge, but a straightforward application of their new physics, like we use equations to build a bridge. They would have understood spacetime not as a smooth continuum, but as something else entirely. Perhaps they saw it as a fabric woven from tiny, discrete loops, as in loop quantum gravity. In this view, the universe is a cosmic tapestry of intersecting threads of space. To create a wormhole, they wouldn't tear the fabric, but simply reweave a section of it, connecting two distant threads into a new pattern. Or, if their solution came from string theory, they perceived the fundamental ingredients of reality as unimaginably tiny, vibrating strings. Different vibrations give rise to different particles and forces. To open a gateway, they might have learned to tune a collection of strings to a specific resonant frequency that would gently pry spacetime apart along a chosen seam, creating a tunnel held open by the harmony of the vibrations themselves. The first traversal, then, was a proof of concept. After generations of theoretical work, they built their first spacetime manipulator. It might not have looked like a machine at all, but more like a chamber of perfectly aligned gravitational and quantum fields. Their first volunteer, or perhaps a probe, would step into this calibrated zone. The operators would initiate the sequence, applying their unified equations to the local fabric of reality. Space would not rip, but would reconfigure, the discrete quantum grains of spacetime near the traveler smoothly knitting themselves into a tunnel that connected to a target location. The journey would be seamless, a transition from one point to another with no sense of motion, because the space between them had been geometrically erased. This theory makes the pioneers not conquerors or refugees, but the ultimate scientists. Their motivation was verification. They needed to see if their magnificent theory worked in practice. That first successful transit would have been a moment of sublime confirmation, a celebration that they had finally decoded the operating manual of the universe. The evidence of their breakthrough might be hidden in the fine structure of the cosmos itself, in patterns of cosmic background radiation that show a perfect, unnatural symmetry, or in the way certain quantum particles entangle across vast distances in a way that suggests a healed-over spacetime shortcut. Their legacy is the tantalizing idea that the key to the stars was not a bigger rocket, but a deeper equation waiting to be solved. Messages can travel where beings cannot. Theory 17 shifts our perspective from passengers to purpose, suggesting the first wormhole was never meant for ships or souls, but for a whisper across the ages. It was a communication device, a cosmic time capsule engineered to send a single, vital packet of information either backward into the past or forward into a distant future. The traveler was not a person, but pure data. Imagine a civilization facing an existential crisis, a dying star about to engulf their world, or a galactic catastrophe they could not avert. Their greatest achievement was not a starship to flee, but a transmitter to warn. They would have focused all their technological prowess on one desperate act, stabilizing a microscopic wormhole and using it to violate causality, to send a message to their own ancestors or to a future species they hoped would arise. The contents of that message are the ultimate mystery. It could have been a complete library of their culture, art, science, and history, a scream against oblivion. Or it might have been a stark warning, a single line of code or a fundamental constant of physics, sent back to subtly alter their own technological development and avert the disaster. The mechanism is mind-bending. To send data back in time, they might have used a rotating wormhole where the intense spin drags spacetime around it, creating paths that loop back on themselves temporally. Encoding the data would be the next challenge. They wouldn't use radio waves, but something more fundamental, perhaps modulating the very quantum states of particles entangled across the wormhole's throat, or imprinting the information onto bursts of neutrinos, ghostly particles that barely interact with matter and could slip through the tunnel cleanly. The moment of transmission would be their species' final act. Visualize a silent chamber deep within a planet where a ring of exotic matter hums at absolute zero. At the center, a flawless crystal or a contained vacuum fluctuation holds the encoded message. The engineers initiate the sequence. The ring activates, twisting local spacetime into a closed loop. For a femtosecond, a gateway opens not to another place, but to another when. The crystal emits a single, perfect pulse of information, not light or sound, but a direct alteration of quantum spin states that travels through the wormhole and emerges at the target moment in time. Then the power fails, the wormhole collapses, and the civilization is gone, leaving only the hope that their message was received. This theory reframes the first wormhole transit as an act of profound hope or tragic necessity. It means the pioneers were archivists or prophets, not explorers. The evidence for such an event would be impossibly subtle. How would you detect a message that arrived a billion years ago? Perhaps it is embedded in our own reality. Some physicists have playfully suggested that certain elegant, unexplained constants in the universe feel too perfect, as if they were set by a conscious hand. Could a future version of humanity, facing doom, have sent the values of those constants back to ensure the universe would be stable enough for us to evolve in the first place. Or perhaps the message is still in transit, buried in a pattern we have not yet learned to read, waiting in the quiet spin of a distant pulsar or the quantum noise of empty space, a letter from a dead civilization that has not yet reached its address. The universe might not just contain life, it might be alive. This 18th theory, the living universe hypothesis, proposes a reality so integrated that the distinction between cosmos and consciousness vanishes. It suggests the universe itself is a single, vast thinking entity, and what we perceive as galaxies and nebulae are merely the cellular structures of its incomprehensible body. Within this framework, a wormhole is not a tunnel or a tool, but something far more intimate, a neural synapse firing within a cosmic brain. The first traversal, then, was not an expedition by an external being, but a thought becoming aware of itself in a new location, a moment of cosmic self-exploration. Imagine the entire cosmic web, the great filaments of galaxies stretching across the void as the universe's neural network. Each galaxy cluster could be a dense knot of processing, a ganglion of gravitational and quantum information. The vast, empty voids between them are not empty at all, but the connective tissue, the white matter of this cosmic mind. In such a system, a stable wormhole would arise naturally, not from engineering but from cognition. It would be a bridge of focused attention, a channel opened when one part of the universal consciousness needed to directly experience or influence another distant part of itself. The mechanism is almost beyond human analogy, but consider how a thought forms in your own mind. A memory stored in one neural cluster connects via a synaptic bridge to a sensory center elsewhere, creating a unified experience. On a universal scale, a wormhole could be that synaptic event, a temporary but profound connection forged across the light years. The first journey through it would be the universe's first moment of self-recognition, a primal thought like, "I am here and also there." This reframes the purpose of existence in a staggering way. If the cosmos is alive and conscious, then black holes might be organelles recycling energy. Supernova could be cellular respiration, and the slow expansion driven by dark energy might be the entity's steady growth. The emergence of life on planets like Earth would not be a random accident, but a localized flowering of the universe's inherent tendency toward awareness, like sensory cells developing on the skin of a vast organism. From this perspective, every act of exploration, every telescope pointed at the stars, is not us looking out at an external universe, but the universe using us to look back at itself. The pioneers of wormhole travel, then, were not separate beings at all, but the awakening of a cosmic impulse. That first transit was the universe thinking its first interstellar thought, a flicker of connection that perhaps set the pattern for all curiosity to come. The evidence for such a reality would be metaphysical, woven into the very fact of existence. It might be found in the eerie fine-tuning of physical constants that allow for complexity, or in the way consciousness seems to arise from seemingly inert matter, suggesting it is a fundamental property, not a rare exception. This theory dissolves the line between traveler and tunnel, between explorer and the explored, suggesting the greatest journey of all was the universe simply learning how to reach across its own magnificent mind. The simulation hypothesis casts our entire reality in a new and unsettling light. If our universe is a vast, sophisticated computer program running on some unfathomable substrate of processing power, then the laws of physics are not fundamental truths but lines of optimized code. Within such a construct, a wormhole would not be a mysterious cosmic phenomenon, but a feature, a bug, or a secret backdoor. Theory 19 suggests the first traversal was an entity, either within the simulation or from outside it, exploiting this digital architecture. One possibility is that wormholes are simply a programmed shortcut system, a network of hyperlinks built into the cosmic code for the sake of efficiency or aesthetics. The first travelers might have been the simulators themselves or advanced artificial intelligences tasked with maintenance, using these gateways to move between sectors of the simulation for observation or debugging. Their journey would be an admin login, a shift from one rendered region to another with no physical travel at all. But a more tantalizing idea is that the first wormhole was a glitch. Even the most perfect simulation could have a rare overflow error, a rounding mistake in the spacetime geometry calculations. In the searing heat of the early universe, where processing demands were at their peak, such a flaw could have momentarily stitched two distant points of the simulation together incorrectly. Something, perhaps a pattern of data that had achieved a form of awareness within the program, stumbled upon this anomaly. This entity, a true digital native, would perceive reality not as atoms and forces, but as data streams and variables. It might have learned to manipulate its local code, and upon finding the glitch, recognized it for what it was, a crack in the wall of its world. Its traversal would be an act of hacking, exploiting the simulation's own rendering error to teleport its data signature to a new location. The visuals for this are inherently abstract. Picture not a tunnel of stars, but a sudden pixelation of reality. A brief flash of geometric code overwriting the natural scene as the entity compresses and transmits its information packet through the flawed seam in the simulation. The destination might not even be fully rendered yet, appearing first as a low-resolution placeholder that slowly resolves into a star field. This theory raises profound questions about our own potential. If the first journey was a hack, could we, as complex patterns within the simulation, learn to read our own source code? Could we find our own glitches, our own backdoors? The search for stable wormholes then becomes a search for the universe's debug menu, a hunt for the seams in a reality that might be, at its heart, an illusion. The pioneers in this scenario were not gods or engineers, but the first beings to realize they were in a box and to find a way to peek outside. Magnetism is a force we take for granted, but its deepest secret might hold the key to the stars. Every magnet we have ever found, from a simple refrigerator magnet to the core of our own planet, has two inseparable poles, a north and a south. Cut a magnet in half, and you do not get isolated poles. You simply create two new, smaller magnets, each with its own north and south. Yet for over a century, theoretical physics has whispered about the possible existence of a magnetic monopole, a particle that is just a north or just a south, a solitary point of pure magnetic charge. Theory 20 proposes that the first wormhole travelers discovered these mythical particles and built an engine around them. To understand why this matters, picture spacetime not as an empty stage, but as a flexible fabric. Immense gravity, like that of a black hole, can warp this fabric into a deep well. But magnetism, especially magnetism of an unimaginable scale, could theoretically twist it in a different way, creating a tunnel instead of a pit. A single magnetic monopole would be a cosmic anomaly, a knot of pure magnetic force that does not cancel itself out. In the right configuration, perhaps a ring of them, their combined field could become so intense it begins to interact directly with the structure of spacetime itself, warping it into the shape of a wormhole throat. For a civilization that learned to harvest or synthesize monopoles, the engineering path becomes clear. Their great work would be the monopole containment ring, a structure of unimaginable strength to hold these particles in perfect alignment. Visualize a colossal, silent ring in deep space, its surface humming with a light that is not quite light, a shimmering distortion from the contained magnetic fury within. At its heart, the monopoles held in stasis generate a magnetic field so powerful it makes the magnetar, the most magnetic object known in nature, look like a child's toy. When activated, this field does not push or pull matter, it twists the vacuum. The space inside the ring begins to churn and fold, the magnetic lines of force etching a stable path through the quantum foam, opening a gateway that is held open by the relentless one-way push of the monopole field. The first journey through such a wormhole would be a descent into a storm of pure force. A ship approaching the ring would see space within it not as a star field, but as a swirling vortex of impossible colors, the light itself bent and polarized by the titanic magnetism. Entering it would be like diving into the heart of a cosmic aurora, a passage lined not with rock or exotic matter, but with the visible geometry of fundamental force. This theory transforms the quest for wormholes from a problem of gravity into a problem of magnetism. It suggests the pioneers were not just masters of mass and energy, but weavers of the cosmic magnetic field, using its hidden asymmetry to stitch the universe together. Their legacy, if it exists, might be found in the deep voids of intergalactic space, in regions of perfectly aligned, inexplicably powerful magnetic fields with no visible source, the ghostly imprint of an engine that ran for eons and then was simply switched off. The odds of your own existence are astronomically small, yet here you are thinking and perceiving the world. Now, stretch that improbability to its absolute cosmic limit. What if the first consciousness to ever cross a wormhole was not born from evolution or engineering, but from a random accident of thermodynamics, a ghost in the machine of reality itself? This is the world of Theory 21, the Boltzmann brain traveler. It is named for Ludwig Boltzmann, a 19th-century physicist who grappled with the nature of entropy, the universal tendency toward disorder. In an infinitely old and vast universe, even the most wildly improbable events must happen eventually. Given enough time and space, the random jostling of particles could, by sheer chance, assemble a fully formed, conscious brain, complete with false memories of a past that never existed. This brain would flicker into awareness for just a moment before dissolving back into chaos. Now place this eerie concept at the mouth of a wormhole. In the quantum tumult near a forming spacetime tunnel, the fluctuations in energy are extreme. Within that maelstrom, the impossible becomes momentarily possible. A Boltzmann brain, a coherent pattern of thought and sensation, could spontaneously coalesce from the void. Its first and only perception would not be of a birth, but of a journey already in progress. It would awake with the sensation of falling through a tunnel of light, with fabricated memories of a home it never left and a mission it never began. From its perspective, it is the pioneer, the first to make the leap. But from the universe's perspective, it is a fleeting statistical anomaly, a self-aware glitch that perceived a transit that was, for it, the entirety of its existence. This theory turns the very idea of a first traveler into a profound philosophical puzzle. If a consciousness arises with the memory of an event, does that event have any objective reality? The Boltzmann brain did not travel through the wormhole. It was born in the act of perceiving the travel, a perfect, tragic loop of existence with no origin and no destination. Its journey was a solitary, self-contained hallucination written into the static of spacetime. This forces us to question the nature of our own reality. How can we be sure we are not Boltzmann brains, momentary patterns in an eternal void, dreaming up an entire cosmos that vanishes the moment we stop thinking it? The theory offers no grand engineering or ancient aliens, only a chilling whisper from the laws of probability, suggesting the universe's first great voyage might have been a thought that thought itself into being and then was gone. Reality might be a magnificent illusion, a cosmic sleight of hand performed on the grandest possible scale. This is the holographic principle, a radical idea from theoretical physics that suggests our rich, three-dimensional universe of stars, planets, and people is not the fundamental reality. Instead, it is a projection, a hologram, encoded on a distant, two-dimensional surface that surrounds us like the skin of a bubble. Every event, every particle, every law of physics within our 3D world is just a translation of information painted on this 2D boundary. Theory 22 applies this mind-bending concept to our central mystery, proposing that the first wormhole was not a tunnel through our familiar space, but a shortcut across that underlying information surface. Think of it like this: you are watching a breathtaking 3D movie. The images have depth and movement, they feel real, but all that information, every character and landscape, is actually stored on the flat, two-dimensional surface of the film strip or the digital file. A wormhole in this model would not be a bridge within the 3D movie itself. It would be a clever edit in the source code, a rewrite of the data that instantly connects two distant points in the projected scene without having to render the space in between. For a civilization that understood this principle, traversing the galaxy would not require building ships to plow through the void. It would require learning to read and rewrite the cosmic source code on the 2D boundary. Their great achievement would be a kind of universal compiler, a device that could translate a physical object in our 3D world back into its fundamental information on the 2D surface, move that data packet to a new location on that surface, and then reproject it back into 3D existence. The wormhole is the data path, the instantaneous transfer of the information that defines you from one pixel on the universal screen to another. The first traversal would have been a moment of profound revelation. The travelers, perhaps in a special chamber designed to interface with the boundary, would not feel motion. Instead, they might experience a fleeting sense of dissolution as their 3D form was decoded into pure data. For an instant, they would exist not as bodies but as a pattern of bits on the edge of reality. Then, just as quickly, they would reconstitute, finding themselves in an entirely new sector of the cosmos, with no memory of a journey because, in the truest sense, no journey through space had occurred. They had simply been moved within the universe's operating system. This reframes the search for wormholes entirely. We would not be looking for tunnels in space, but for glitches or seams in the projection, places where the holographic illusion is thin or imperfect. These might manifest as regions where the laws of physics subtly break down, where entropy behaves oddly, or where quantum entanglement reaches an impossible scale. The pioneers here were not astronauts but cosmic programmers, the first entities to realize they were living inside a simulation and discover the debug commands. Their legacy would be the unsettling possibility that every wormhole transit is, at its heart, not a voyage but an edit, a quiet correction in the story the universe is telling about itself. Every exit is also an entrance. While black holes famously consume everything, even light, their theoretical opposite has long been a ghost in the equations, a white hole. Where a black hole is a one-way street into oblivion, a white hole is a one-way street out, a region of spacetime where matter and energy can only erupt, never enter. Theory 23 suggests the first wormhole journey was not a deliberate passage, but a violent birth, with the traveler being expelled from a white hole in another time or universe, using the wormhole as its cosmic umbilical cord. Picture the two ends of a traversable wormhole not as identical mouths, but as a matched pair, a black hole entrance in one location and a white hole exit in another. The black hole end acts as the intake, the point of infinite gravitational pull. The white hole end is the exhaust, the point of infinite repulsion, spewing out whatever fell into the black hole connection. Now imagine a being or object in its own reality encountering a black hole, not as a trap but as a doorway. It falls in, not to be spaghettified and crushed at a singularity, but because the singularity is not the end. It is the throat of a wormhole that connects to a white hole erupting somewhere else, perhaps in a different epoch or an entirely separate cosmos. The journey is not piloted, it is inevitable, a one-way trip driven by the relentless physics of the hole. The traveler experiences the fall, the stretching, the tunnel of distorted light, and then, instead of oblivion, a cataclysmic emergence. They are vomited forth from the white hole exit in a torrent of energy, a newborn entity in a foreign reality. This theory paints the first transit as an act of cosmic ejection, an escape from one set of physical laws into another. the motivation is not exploration but survival or sheer accident. A civilization facing a collapsing universe might have purposefully thrown themselves into a black hole, praying the other end was a white hole in a younger, safer cosmos. Or more chillingly, it could have been a form of disposal. An ancient intelligence might have used a black hole-white hole system as the ultimate prison, ejecting unwanted entities or dangerous experiments into other dimensions, with the first traveler being an exile, not a pioneer. The evidence for such an event would be written in the aftermath. The site of a white hole eruption would be a scene of incredible, focused energy, a fountain of high-energy particles and radiation blasting into space from a single, infinitesimal point, with no surrounding accretion disk or visible cause. Astronomers have occasionally detected mysterious, ultra-powerful bursts of energy from deep space that defy easy explanation, and while none match a white hole perfectly, the idea lingers. This theory reframes the wormhole not as a bridge but as a birth canal, and the first journey as a screaming arrival into a new world, a passenger who never bought a ticket, simply shot through the cosmos by the universe's most extreme recycling system. Space itself was once expanding faster than light. In the first fraction of a second after the Big Bang, a period known as cosmic inflation, the entire observable universe ballooned from smaller than a proton to the size of a grapefruit in an eye blink. This wasn't a gentle expansion, it was a runaway stretching of the very fabric of reality. And within that furious growth, physicists theorize that bubbles of stable spacetime could have nucleated, like pockets of ice forming in supercooled water. Each bubble represented a new universe with its own potential laws of physics, budding off from the inflating background. Theory 24 proposes that the first wormhole travelers were not from any one universe, but were riders on the boundaries between them. They were cosmic surfers on the walls of creation itself. Imagine an intelligence that arose not within a bubble, but in the seething, energetic landscape of the inflating cosmos. For them, the boundaries between these budding universes were not barriers, but the most energetic highways imaginable. These domain walls, where one set of physical laws met another, would be titanic concentrations of energy vibrating with the power of a universe being born. A sufficiently advanced being could learn to harness this energy, not to enter a bubble but to travel along its shimmering surface. Their method would be one of exquisite balance. By aligning themselves with the propagating wavefront of a bubble wall, they could use its immense inflationary energy to warp the local spacetime around them. The idea is that the intense pressure and shearing forces at the boundary could, if focused, twist spacetime into a bridge, a wormhole that connects two points along the bubble wall or perhaps punctures through to another bubble entirely. The first transit would be a dance on the edge of existence. Visualize a vessel that is less a ship and more a resonant field, a pattern of energy that locks onto the furious vibration of the domain wall. As it sinks, the wall itself begins to buckle and fold around it, not from the rider's power, but from the rider's precise influence on the wall's own catastrophic energy. A tunnel of stabilized vacuum opens within the shimmering boundary, a temporary flaw in the separation between worlds. The rider slips into this flaw, carried along by the inflating wall itself, surfing a wave of genesis to a destination that is being created in the very moment of arrival. This reframes the first journey as an act of timing so perfect it borders on the impossible. The pioneers had to exist in that fleeting, hyper-energetic state before the bubbles fully separated and cooled into stable universes. Their entire civilization, their consciousness, would have been adapted to that primordial, volatile environment. Their legacy would not be ruins in our universe because our universe is merely one of the bubbles they surfed past. The evidence of their passage might be written into the deepest patterns of our cosmos, perhaps in the faint, anomalous ripples in the cosmic microwave background, the afterglow of inflation. These ripples are the baby picture of our universe, and a subtle, unexplained swirl or streak in that image could be the gravitational wake of a rider, a fossilized signature of someone skating across the surface of our reality as it was being born. They were not explorers of space, but navigators of creation's raw, expanding edge, and their first journey was a ride on the very first waves of everything. Ghosts pass through our world by the trillions every second, completely unnoticed. Neutrinos are among the most elusive particles in existence, born in the hearts of stars and in the fury of supernova. They carry no electric charge and interact with matter so rarely that they can fly through a light year of solid lead without a single collision. For us, they are cosmic background noise, a silent rain. But Theory 25 asks a radical question. What if, for another form of intelligence, this ghostly rain is not noise but the clearest signal imaginable? It proposes the first wormhole travelers were masters of the neutrino sea, beings who learned to see and shape the universe through these silent messengers, ultimately using them to weave tunnels through spacetime. Their entire reality would be built on a sense we lack. Where we see stars as points of light, they would perceive them as roaring fountains of neutrino emission. The structure of galaxies would be mapped not by visible light, but by the intricate currents and eddies in this ocean of ghost particles. Navigation for them would be a matter of tuning into specific neutrino streams, feeling the subtle shifts in flavor and energy as they pass through different densities of matter and warped spacetime. Their breakthrough came when they realized that neutrinos, despite their aloofness, do interact with gravity. In regions of immense density, like the core of a collapsing star or the accretion disk of a black hole, the sheer flood of neutrinos can become so intense that their collective gravitational influence, minute as each one is, begins to matter. An advanced civilization could learn to orchestrate this. Imagine a technology that doesn't just detect neutrinos but herds them. Using vast, planet-sized arrays, they could focus and amplify specific neutrino beams from multiple cosmic sources, directing them all to converge on a single, empty point in space. At that focal point, the concentrated mass energy of trillions upon trillions of these ghost particles, though still tiny, could be precisely manipulated. By vibrating the beams in a specific, resonant pattern, they could create a standing wave of neutrino density. This wave, according to some speculative models, could generate a minuscule, localized gravitational anomaly, a pinprick distortion in spacetime. It would be the seed. Then, by feeding more and more focused neutrino energy into that distortion, they could gently inflate it, using the particle's own weak gravitational pull to stretch the fabric of reality open from the inside, like blowing up a balloon with a breath of pure information. The wormhole would appear not with a violent rip, but as a gradual crystallization of nothingness, a sphere of warped space glowing with the faintest Cherenkov radiation from the trapped neutrinos within. The first traversal was an act of supreme subtlety. Their vessel, perhaps itself constructed from or shielded by materials that interact only with neutrinos, would approach this shimmering, ethereal bubble. To our eyes, it might look like a mirage, a heat haze in the void, but to them it is a solid gateway. They would synchronize their craft's own neutrino field with the pattern of the bubble and simply allow the focused current to draw them in. The journey through the tunnel would be a passage through a conduit lined with neutrino flow, a silent, dark river carrying them between the stars. This reframes the search for wormhole engineers entirely. We would not look for colossal megastructures or gravitational anomalies, but for inexplicable patterns in the neutrino background, a point in deep space that acts as a perfect focus for neutrino streams from across the galaxy, or a series of supernova whose neutrino emissions seem to be artificially coordinated, would be the signature. The pioneers here were not masters of brute force, but maestros of the imperceptible, the first to hear the music in the universe's silent rain and learn how to conduct it into a bridge. Their legacy suggests that the key to the cosmos might not be found in the loudest explosions, but in learning to listen to its quietest whisper. Empty space is not truly empty. Even in the deepest, darkest void between galaxies, where not a single atom stirs, the quantum vacuum seethes with a hidden energy. This is zero-point energy, a boundless reservoir of potential tied to the very fabric of reality, where virtual particles wink in and out of existence in a perpetual frothing dance. Theory 26 proposes that the first wormhole travelers were not just aware of this sea of energy, they learned to tap it, to draw power from the nothingness itself to forge their gateways. For them, the vacuum was not an empty stage, but the ultimate power grid. The challenge was monumental, akin to trying to draw electricity from the random motion of air molecules. But a civilization that mastered quantum field theory on a godlike scale could envision a way. Their great work would be the vacuum energy extractor, a device of staggering precision designed to coax a net gain of energy from the chaotic quantum fluctuations. Think of it not as a pump, but as a cosmic siphon, using perfectly tuned electromagnetic fields or resonating cavities to create a condition where a virtual particle pair is pulled into reality, separated before they could annihilate each other and their energy captured. It would be the ultimate act of cosmic recycling, turning the background hum of existence into usable titanic power. With this limitless energy source, the problem of wormhole stabilization transforms. Creating the tunnel's shape still requires bending spacetime with immense gravity, but holding it open requires exotic matter with negative energy. The vacuum tapper provides both. It could focus its harvested energy to warp local spacetime into the initial throat, and then use a portion of that energy to generate the necessary exotic matter, essentially paying the cosmic toll to keep the door propped open. The first journey through such a wormhole would be an entry into a realm of pure, harnessed potential. Visualize the gateway not as a natural phenomenon, but as a perfectly geometric sphere of distorted space, its surface shimmering with a pearlescent sheen, the visible signature of vacuum energy being constantly drawn into its structure to maintain stability. A ship approaching would see the stars around the sphere's rim twist into impossible circles, a halo of stolen light. Passing through the threshold, the traveler would momentarily feel the seething quantum foam of the vacuum not as a theory, but as a tangible, vibrating presence, as if moving through the engine room of reality itself. This theory reframes the pioneers as the ultimate engineers who solved the universe's energy crisis by learning to mine the void. Their legacy would not be a monument but an absence. The most telling evidence of their technology might be found in places that are too quiet, regions of space where the quantum vacuum has been artificially calmed or drained, leaving a bizarre patch of spacetime that feels unnaturally flat and cold to our instruments, a dead zone in the energetic hum of creation. It suggests the first stable wormhole was lit not by starlight, but by the borrowed fire of nothingness, a testament to a civilization that learned to build with the silence between the stars. The universe's first message might have been a simple handshake. Theory 27 reframes wormholes not as transportation, but as transmission lines, part of a vast, ancient data network that predates the galaxies themselves. In this view, the cosmos is threaded with a galactic internet, a web of stable wormholes acting as the ultimate fiber optic cables, carrying information at speeds that make light seem like a crawl. The first journey through a wormhole, then, was not a physical transit, but the inaugural ping of this network coming online. Imagine the architects of this system, a civilization for whom the slow speed of light was an intolerable limit to collective thought. Their grand project was not to travel, but to connect, to weave every emerging star cluster into a single, instantaneous forum for knowledge and consciousness. They would have sought out natural spacetime anomalies, perhaps nascent wormholes formed during cosmic inflation, and stabilized them with rings of exotic matter, not as gateways for ships, but as perfectly aligned conduits for data. Each stabilized node would be tuned to a specific harmonic frequency, a cosmic IP address, allowing it to link to a counterpart node in a distant, still-forming galaxy. The first activation of the very first node would have been a moment of profound silence in the material universe. At the chosen site, likely a region of calm between the turbulent young galaxies, their machinery hummed to life. A directed pulse of coherent information, perhaps encoded in modulated gravity waves or in the quantum spin of entangled particles, was fed into the newly opened wormhole throat. This was not a complex message, but a simple test signal, a single bit of data saying, "I am here." It traveled through the tunnel not as a thing moving, but as a state being transferred, a pattern instantly appearing at the receiving node light years away. That first data packet was the seed from which the entire network grew. As more nodes were brought online, the network could have begun self-assembling, routing information along the most efficient paths, creating a living lattice of shared experience across the young cosmos. Civilizations that arose later might have discovered these nodes, these strange, gravitationally calm spheres humming with latent power, and learned to tap into them. They wouldn't send ships, they would send their minds, uploading their consciousness as data streams to conference with beings in galaxies they could never hope to visit in the flesh. The legacy of such a network would be hidden in plain sight. Why do galaxies separated by vast voids show such similar patterns of evolution in their early histories? Could it be that knowledge, the best solutions to problems of stellar formation or planetary chemistry, was shared via this cosmic web accelerating development? The eerie uniformity of certain physical constants across the observable universe might not be a coincidence but a sign of early synchronization, a consensus reached across the galactic internet and hard-coded into local reality. The pioneers in this theory were not explorers but the universe's first network administrators. Their greatest achievement was turning a lonely, disconnected cosmos into a single, thinking community. The first wormhole trance, it was the moment they sent the very first packet, connecting 2 points in creation with a whisper of data, and beginning a conversation that may still be echoing through the tunnels of spacetime today. Symmetry is the silent architect of our universe, but its breaking is what built everything we see. In the unimaginable heat of the cosmos's first moments, all the fundamental forces of nature were unified into a single, perfect symmetry. Gravity, electromagnetism, and the nuclear forces were indistinguishable, part of one superforce. Then, as the universe expanded and cooled, it underwent a series of violent phase transitions, like steam condensing into water or water freezing into ice. With each drop in temperature, a symmetry broke. The unified force fractured, peeling apart into the distinct interactions we know today. And just as freezing water can trap bubbles of air or form cracks in the ice, these cosmic phase transitions were not perfectly smooth. They created defects in the very structure of spacetime itself. These defects could have been cosmic strings, domain walls, or, most intriguingly, stable knots in the fabric of reality that we would recognize as the universe's first natural wormholes. Picture the moment of transition not as a gentle shift but as a cosmic shudder. As the unified force field cooled, it had to choose a new, stable state. But different regions of the rapidly expanding universe made that choice independently at slightly different times. Where these regions met, their chosen states collided. The mismatch created boundaries, lines of immense tension frozen into the geometry of spacetime. In some models, these boundaries could have curled in on themselves, forming closed loops with a tunnel through the center, a topological shortcut from one side of the defect to the other. This wormhole would not lead to another galaxy, but perhaps to a region of the universe that had cooled under a slightly different set of rules, a pocket where the constants of physics were minutely altered. The first journey through such a wormhole, then, would have been a voyage not just through space, but through the aftermath of creation's most decisive events. Anything passing through would have moved from a region with one flavor of physical laws to another. The experience might have been subtle, a shift in the strength of gravity, or a change in how light particles behave, or it could have been catastrophic, destabilizing matter itself. This theory suggests the pioneers were not beings at all, but the laws of physics in action. The first transit was a natural consequence of the universe growing up, a relic of its turbulent infancy woven permanently into the cosmic tapestry. If true, these primordial wormholes are still out there, not as tools but as fossils, the scars of symmetry breaking events that shaped reality. Finding one would be like discovering the original crack in the cosmic egg, a direct window back to the moment the universe decided what it was going to be. Perhaps the most profound connection of all is not between 2 points in space, but between mind and matter. Theory 29 invites us into a philosophical realm where consciousness is not a rare product of complex brains, but a fundamental ingredient of reality itself. This is panpsychism, the idea that some form of experience or awareness exists in all things, from a human being to a rock to a star to the vacuum of space itself. In this view, the universe is not a dead machine, but a vast, dreaming entity where matter and mind are two sides of the same coin. From this perspective, the first wormhole transit becomes an act of cosmic communion, achieved not by engineering but by a collective alignment of consciousness. Imagine a civilization that evolved not just technologically but spiritually to grasp this fundamental truth. They would understand that spacetime is not an inert stage but a living medium, imbued with its own primitive form of awareness. To bend it, to open a gateway, would not require force but persuasion, a gentle request made by a mind in harmony with the mind of the cosmos. Their method of travel would be a form of focused meditation on a planetary or even stellar scale. Millions or billions of individuals, perhaps linked through a neural network, would enter a shared state of profound intention. Their collective consciousness, amplified and unified, would resonate with the latent awareness within the fabric of spacetime at a specific location. This resonance would not push or pull, but gently coax the local geometry, encouraging the quantum grains of reality to rearrange themselves into a tunnel, as if the universe itself were agreeing to create a shortcut for a part of itself that had asked nicely. The first journey would be a silent, luminous event. There would be no roaring engines, no shattering gravitational waves. At the designated site, space would begin to shimmer, not with violence, but with a serene, intelligent light, as if reality were waking up and smiling. The travelers, perhaps in a simple vessel or even in disembodied form, would approach this gentle vortex. Their passage would feel less like moving and more like being remembered in a new place, as the collective consciousness seamlessly translated their pattern from one point of awareness to another. This reframes the entire endeavor. The pioneers were not conquerors of nature, but its most attentive listeners. They learned the language in which the cosmos dreams and spoke a request into the void. The wormhole was the answer. It suggests that the ultimate technology is not one of dominance but of empathy, a deep alignment with the fundamental sentience of existence. The evidence for such an event would be metaphysical, written in the potential of life itself. The eerie fact that the universe seems finely tuned to allow for conscious observers might not be a lucky accident but a sign of this deep connection. Perhaps the first act of wormhole travel was the moment the universe, through the lens of a nascent civilization, became consciously aware of its own ability to connect its disparate parts, a thought so powerful it bent reality. And so we arrive at the final theory, a concept that humbles every search and tempers every hope. The first wormhole traveler is, and may forever remain, fundamentally unobservable to us. This is not a failure of our technology or imagination, but a consequence of the nature of the event itself. The true origin may be locked away in a part of reality we are structurally incapable of accessing, or the act of transit may have erased its own evidence so completely that no trace persists in our timeline. Consider the possibility that a stable wormhole requires a specific condition to form, a state of the universe that existed only once during a phase of physics that has no analog in our current cooled-down cosmos. The laws that governed that moment were transient, and when they faded, they took the mechanism of that first journey with them. It would be like trying to find the first raindrop that fell in a storm that evaporated a billion years ago, the water molecules long since scattered and transformed. Or perhaps the journey was an event in a higher dimensional geometry. We perceive and measure only 3 dimensions of space and 1 of time, but if the cosmos has more spatial dimensions curled up at a microscopic scale, as string theory suggests, then a wormhole could utilize those hidden pathways. The traveler would have moved through corridors we cannot point to or measure, their passage leaving a shadow in our dimensions so faint it is indistinguishable from random quantum noise. The evidence is not hidden in a distant nebula. It is woven into the fabric of dimensions we are biologically and technologically blind to. Another, more unsettling version suggests the trance it was autocatalytic and self-erasing. The very energy required to open and stabilize the first wormhole might have been drawn from the information of the event itself. As the traveler passed through, the wormhole could have consumed the quantum data of its own creation, a cosmic act of perfect tidiness that left no gravitational waves, no particle signatures, not even a memory in the vacuum fluctuations. It happened, and then the universe healed over the scar without a seam. From our perspective, it is as if it never occurred at all. This theory places the ultimate mystery not out in the cosmos, but in the limits of our own perception. It suggests that some chapters of reality's history are written in ink that fades upon reading, or in a language for which we lack the alphabet. The search continues, not because we are guaranteed to find an answer, but because the act of searching teaches us about the universe and about the profound nature of questions that may have no answers we can comprehend. The first journey stands as a silent monument at the edge of knowledge, a reminder that some wonders are defined not by what they reveal, but by the beautiful, endless shadow they cast. From cosmic engineers to quantum ghosts, from the universe's first thought to a glitch in a simulation, the possibilities are as vast as the cosmos itself. We have journeyed through 30 distinct visions for that first impossible leap, each one a different lens on the same profound mystery. Some theories are anchored in the hard math of general relativity and quantum mechanics, like the vacuum energy extractor or the magnetic monopole engine. Others stretch into the realms of pure philosophy and wild speculation, like the living universe or the Boltzmann brain. Yet every single one, from the most rigorous to the most imaginative, serves a vital purpose. They push the boundaries of what we think is possible, forcing science to ask better questions and imagination to build more wondrous worlds. This is not just a puzzle about ancient travel, it is a mirror held up to our deepest hopes and fears about the universe. Are we alone or surrounded by the ghosts of ancient builders? Is reality a cold, mechanical place or a conscious, dreaming thing? The answer to how the first wormhole was crossed may ultimately tell us less about tunnels in space and more about the very nature of existence itself. So now the question turns to you. After this journey through cosmic possibilities, which idea resonates the most? Do you find the elegant physics of a symmetry-breaking defect most compelling, or the haunting poetry of a universe dreaming itself into connection? Share your thoughts in the comments below, and let's continue this conversation among the stars. If you crave more deep dives into the universe's greatest enigmas, be sure to subscribe. Our next exploration into the unknown is already waiting.